Day 452 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2411, smallest subarrays with maximum bitwise OR. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a zero-indexed array nums of length n consisting of non-negative integers. For each index I from 0 to n minus 1, you must determine the size of the minimum size non-empty subarray of nums starting at I inclusive that has the maximum possible bitwise OR. In other words, let Bij be the bitwise OR of the subarray I up to j. You need to find the smallest subarray starting at I such that bitwise OR of this subarray is equal to the max of Bik, where I is less than or equal to k and k is less than or equal to n minus 1. The bitwise OR of an array is the bitwise OR of all of the numbers in it. Return the integer array answer of size n, where answer of I is the length of the minimum size subarray starting at I with the maximum bitwise OR. A subarray is a contiguous non-empty sequence of elements within an array. All right, y'all, so that sounds simple enough, or does it? It doesn't really sound that simple, actually. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 1, 0, 2, 1, 3. Our output is an array of integers 3, 3, 2, 2, and 1. So let's go through these explanations so we can see and understand how we got this output from this input. This input right here. So the first thing the explanation says is the maximum possible bitwise OR starting at any index is 3. So first thing we want to do is, it says right here, what does it say? Sorry, y'all. It says right here, it says the bitwise OR of an array is the bitwise OR of all of the numbers in it. So when we want to find the maximum possible bitwise OR starting at any index. So if we take this whole array and bitwise OR this whole array, we're going to get 3, and I'll show you how. So and 3 is the maximum bitwise OR that we can get, but I'm gonna show you how this whole array equals to 3. So first thing we do, we're starting with 0, right? So we start at 0. We won't have to put the 0. Then we start at 1. So 1 would be, we're gonna start with 0 just so we have something to compare with 1. So we add a 0. We'll start at 0. Then we're going to come down and we're going to bitwise OR with 1. So that's going to be 0, 0, 1, right? So the bitwise OR, how it works is if there is a 1 in the comparison, you see we're comparing the top number with the number underneath it, right? So with this, if there's a 1 in that comparison, then the output for the OR, bitwise OR, is going to be 1, right? So this would be 1. We could just put a vertical line for the let you know this is what the OR equals. Boom. So hold on, let me line this up for y'all. So boom, this is a 1. If there's no 1, then it's a 0. So it's just gonna be 0, 0, 1, right? But that's because we started at 0, so you can understand 1 is going to be 1 again, right? So boom. So now we have 1. Now we take this 1 and we are going to compare this 1 with 0 again. But this time we're comparing it with 0 because 0 is the next index in the array. Or the next element in the array. This first 0 we just started because since 1 was the first element in the array, we needed something to start our count off with, so we're going to start our count off from 0. But this second 0 is coming because 0 is the second element in an array. So now we are going to compare 1 to 0. So once again, we can do this 0, 0, 1, then 0. That's once again, that's going to be 0, 0, 0. Same thing, right? We compare the 1 with the 0, that's going to get us a 1. And then these two, there's no 1s in this comparison, so that's a 0. And there's no 1s in this comparison, so that's a 0. Boom. So now we're still at, sorry y'all. Now we're still at 1. Boom. That's the bitwise OR of this. So now we're going to take this and we are going to compare this with 2 because 2 is the next element in the array. So we could just say this equals 1. Boom. Let's clean that up a little bit. Boom. So now, once again, the next element in the array is 2. So we're going to compare 2 with this 1. So 2, that's going to equal, so 2 in binary is going to be 0, 1, 0. So we just put 0, 1, 0. Now, this is going to be, once again, so after comparison, we have a 1 in this when we compare these two bits. So we can put a 1 right here. This time we have a 0 and 1, so this one has a 1 as well. Boom. And then this has 0, so it's a 0. So once again, this is how the bitwise OR works. If there's a 1 in the comparison, then the output is going to be 1 for that bit. And if it's not a 1 in the comparison, then the output is going to be 0. So since this has a 1 in the comparison and this has a 1 in its comparison, that's how we got these 1s right here. And there's no 1 in this comparison, and so that's how we've got a 0 right here. Boom. And that's how this bitwise OR operator works. So now we're right here. So that's after we compared the two. So now the next element in the array is another 1. So now we're going to do, compare this with 1. So 1 is going to be 0, 0, 1 again. And just so y'all know, this would equal 3. Boom. But we're not done yet because that's only once we got to here. We're doing the whole array. So right now we're at 1. Boom. So now we have to compare that 3 with 1. Sorry, y'all. Boom. So now after we compare these with the bitwise OR, this has a 1 in it. So once again, this is going to be 1. Sorry, y'all. That's going to be 1. This has a 1 in it, so that's going to be 1. 0. So that's going to be a 0. Boom. Once again, that's going to equals 3. But we're not done yet. But we could put the 3 there just because. I hope that 3 doesn't confuse y'all because we're not done yet. That's when we get to 1. So now we compare 3 with 3. Because 3 is the last number. So now we come down here, we're going to compare the last number. So then so this will be 3, and once again, that's going to be 0, 1, 1. And when we're done with all this, our output is going to be 3, because once again, this has a 1 in it. So we can start from this side. This has a 0 in it, so we go 0. Then this has a 1 in it, this comparison, so it's a 1. This has a 1 in it. Boom. So this is our maximum. This is our maximum bitwise OR from this array is 3, right? As you can see, we got 3 multiple different times, but in the end, 3 is the maximum, right? Only other elements we had was a 0, 1, and a 2, 3 being the maximum. So that's how right here, the maximum possible bitwise OR starting at the index is 3. So our maximum bitwise OR is 3. That's how we got it when we did all of the elements. So boom, that's just the first part. That's just how we got the maximum. So we have the maximum. Now what we need to do is we need to find all of the subarrays, and a subarray is a contiguous non-empty sequence of elements within an array. So it has to be contiguous, meaning it has to go from index I to index I plus 1 to index I plus 2, and so on and so on. Or whichever index I, once again, could be anything. This could be index I, this could be index I plus 1, this could be index I plus 2, but it has to be contiguous, has to be in order. A non-contiguous would be like, say we started here, we might could delete this one and then we just go to this one, go to this one and delete this one, or just we could delete some. But in a contiguous subarray, we cannot delete anything. They all have to be contiguous, meaning we have to continue down the array. We can't just skip over elements or delete elements like we could in a non-contiguous, non-empty subsequence. So the first array we find, or the first subarray we find, is starts at index 0, and the shortest subarray that yields 3 is 102. So this subarray right here. So as you can see, if we did the bitwise OR on 102, if we did the bitwise OR on this, it would equal 3, right? And I'll show you how. So once again, we could just start from 1. So 1 would be 001. We compare that. So this how it works too. So first we compare the first elements first. So it would be something like this. It would be first we do this, that'll be in 1, then it'd be 0. So we do this first. And then we compare what this output is, and then we would compare the 2, when the 2 would be 010. So it'd be like, this is how it works. First we're going to compare these two numbers, then we take the output from these two numbers and compare that with the next number, and so on and so on, just so y'all understand that part as well. So first we're going to do 001 and 000, right? Because we're going to do the 1 and the 0, and once again that's going to get us 001. Why? Because no ones in this comparison, 0. No ones in this comparison, 0. It's a 1 in this comparison, so it's 1. So boom, then we have 1. Now we compare this to 2, and this 2 would be 010. So when we compare this, it's going to be 011, because it's 0s in this comparison, then it's a 1 in this comparison, and it's a 1 in this comparison. So that's 3. 011 is equal to 3 in binary, right? So that equals 3. So this this subarray equals 3, and so on. We're not going to go through all of these examples, but just trust LeetCode when it tells us that all of these examples, they all equal 3. This bitwise OR would be 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 3. And this bitwise OR would be 3. And that's just the first example of how this bitwise OR equals 3. I encourage y'all to go through all of these just so y'all could get a better understanding of how the bitwise OR works, and just so you can visualize what's going on. But this is just a visualization of this first one. So boom. So now that we have all of our subarrays that equal 3, bitwise OR equals 3, right? So it says starting at index 0, the shortest subarray that yields it is 102. Then starting at index 1, the shortest subarray that ends it yields the maximum bitwise OR is 012. So that would be this subarray. Then we do this subarray. Then we do this subarray. And then we just do this. Boom. So once again, they all equal 3. But we're not done yet, because we still need to return this output. So this output, we're counting the length, right? So it says return an integer array answer of size n, where answer of I is the length of the minimum size subarray starting at I with the maximum bitwise OR. So the length of this subarray is 3. So we return 3. We put a 3 right, or we append 3, I should say. We put a 3 right there in the array because the count is 3. Similar with this. This has a count of 3. There's 3 elements, 1, 2, 3. So we put a 3 right here. This has 2 elements, 1, 2. Put a 2 right here. This has 2 elements, 1, 2. We put a 2 right here. And this has 1 element. So boom, we put the 1 right here. So I hope that makes sense to y'all. And now that, or excuse me, let's go ahead and take a look at example 2. I'm moving too fast. Sorry about that. Let's take a look at example 2. Example 2 we should get through quickly. So example 2, we have our input nums equals an array of integers 1 and 2. Output is 2 and 1. explanation says starting at index 0, the shortest subarray that yields the maximum bitwise OR is a length of 2. So it would be just this whole array. So we put a 2 when we start from index 0, right? So since this has a count of 2, just be 2. Then starting at index 1, the shortest subarray that yields the maximum bitwise OR of length 1 would be just this 2 right here. So since it would only be this 2 as a count of 1, right? So the first subarray would be this 1 and 2 has a count of 2, so we put 2. Second subarray would just be this single 2, so we put a 1 because it's just one element in that array. So that's why we return 2 and 1. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution not that difficult to understand at all. So let's get into it. First thing we're going to do, we're going to create a variable that will store the length of the smallest subarray for each starting index. So to do that, we can just declare a variable, call it ands, and we can set that equal to an array of integers. Put the parentheses outside because, as you can see, our output is an array of integers, so we need to create that an array of integers, and that's what this is going to be right here. Boom. Now we're going to declare a variable called prev, and that's going to keep track of the most recent index from right to left, where each of the 32 bits was last seen as 1 in the array. So we're going to declare a variable called prev, and we are going to set that equal to an array. Open up the parentheses, it's going to have repeating colon -1 comma count colon 32. Then we're going to traverse from right to left. So we're going to say for I in stride, open up the parentheses, from colon nums.count -1 comma through colon 0 comma by colon -1, come outside of that, open up the brackets. So we're going to declare a variable called x, and we're going to set that equal to nums square bracket I, and that's going to be the current number. Then we're going to declare a variable called j and set that equal to 0, and that's going to be the bit position counter, and it's going to go from 0 to 31. Then we're going to declare a variable called end, and we're going to set that equal to I, and that's going to be the farthest index needed so far for the starting position. And then we're going to declare a variable called cur, and we're going to set that equal to prev, and that's going to be a copy of prev to update for this position. Now we need to extract the bits of current number and update cur. So for that, we come right here, we'll say while x is greater than 0, we'll open up the brackets, and we are going to say let dig equal x mod 2. And that's going to be the last bit, which is it's going to be either 0 or 1. Then we're going to say if dig equals 1, then we can open up the brackets, and we're going to say cur square bracket square bracket j equals I. Then we could come underneath that. So if bit I is 1, then we're going to update its last seen index to I. Then we need to shift right by dividing that by 2. So come outside of these brackets and underneath, and we're going to say x divided by equals 2. Come underneath that, and we are going to increment j by saying j plus equals 1. Boom. Now we need to determine the farthest index needed, so all bits seen so far are included. So in order to do that, we could come right here. We'll say for kn 0 ... less than cur dot count, where cur square bracket k exclamation point equals, so does not equal -1. We're going to open up the brackets. We're going to say end equals max, open up the parentheses, end comma cur square bracket k. Boom. Now we're going to store the length of the smallest subarray starting at I. So we're going to come right here. We're going to say ands.append, open up the parentheses, end minus I plus 1. Then we're going to update pre for the next iteration, right? So the next number to the left by saying, coming underneath this and saying pre equals cur. Now we need to reverse this because we processed from right to left. So we come right here and we're going to say return ands.reverse and put the parentheses. That should be all she wrote, y'all. Let's go ahead and give it a run before we submit it. Make sure it works correctly. Okay, it should be equal white space. So let's see. Let's run it again. See if it works this time. And it's accepted. So let's submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 15 milliseconds beats 100% of users. That's what I'm talking about. Those are some good numbers right there. So with that being said, y'all, make sure you get one more look at the code. This is the top part. This is the bottom part, y'all. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.